In this video, we're going to introduce exponential models. So let's start with population growth, and this will actually serve as our model throughout. So let's suppose there's a one-cell organism that splits into two one-cell organisms in an hour. How many organisms will there be in t hours? Well, certainly at time 0, initially, there's one organism. And that's a typo. Let's just say organism, not organism. I don't know what an organism is. But at time 0, there's 1, which you can rewrite as 2 to the 0. At time 1, there's 1 times 2. It splits into 2, or 2 organisms, which we can write as 2 to the 1st. At time 2, it doubles each hour. So each one-cell organism can make another one. It splits into 2. So now there's 4 organisms, or 2 squared organisms. And in general, it doubles each time. So at time 3, it'll be 2 cubed. At time 4, it'll be 2 to the 4th. Notice all we're doing is doubling the previous number of organisms that we have at any time. So at time t, there would be p of t equals 2 to the t organisms. And this is an example of exponential growth. More generally, if we want the population at any time, the growth of that population will be proportional to its size, in this case, to get exponential growth, then we can write the population in the form p of t equals p naught a to the t. The p naught represents the population at time 0. And notice that, again, if we put 0 in for t, in this case, you'll get p naught times a to the 0. Or just get a piece of 0. So that is the initial population, whatever number they give you at the beginning. So let's do an example. 100 rabbits are released into the wildlife refuge. They have no natural predators. So basically, they have no barriers to how they can grow. So it should be proportional to their size, which means it's going to be exponential growth. In 1 year, there's now 500 rabbits. How many rabbits will there be in 10 years? Well, initially we had 100 rabbits, so that tells us our piece of 0 is 100. When we put 1 into our model, we're supposed to get 500 out. We told that there are 500 rabbits a year later. Well, our exponential model was that p naught a to the t. We need to figure out what a is. We know that p naught is 100 and t is 1. So we can solve for a. We get a is 5. So our model now looks like 105 to the t. It asks how many will be in the refuge after 2 years. Well, we can plug in 2 for t. We get 100 times 5 squared, or 2,500 rabbits. Let's do an example with inflation. A television costs $309 1 year from today, and $337.65 in 4 years from today. Problem asks us for the price of the TV today and how much it'll cost in 10 years. Again, we're going to assume that inflation grows proportional to, a price will grow proportional to its current price. So we'll assume that we have exponential growth here. We know that when we plug in 1, we're supposed to get 309 out. When we plug in 1 into the model, we get p naught times a. We know the price 4 years from today is 337.65. So when we plug in 4 in for t, we should get the 337.65. This is a typo. This should say 4, not 5. It should say p of 4 equals 337.65. We're going to figure out what a is by dividing the two equations. So we'll do p naught a to the 4th over p naught times a is 337.65 over 309. That tells us that a cubed is this 1.09 and change number. Taking the cube root of that, we get 1.03. So our a is approximately 1.03 in this case. So now we have our model. We can figure out, we have the a for our model. We can also figure out the p naught. Go back up to the original equation for p of 1. Plug in the 1.03 for a. We can solve for p naught by dividing and get our p naught was $300. Now we have our model. P naught was 300, a is 1.03. We want the cost in 10 years, so we want to compute P of 10. When we do that, we get $403.17. We can also do what's referred to as exponential decay. We do exponential decay the same way we do exponential growth. It's just going to turn out that with the exponential decay, the A value will be between 0 and 1. All right, so let's say we have a population that has that's decreasing. A town that has a population that's decreasing. It's 250,000 now, but it's estimated the population is going to dwindle to 100,000 in 25 years. Assuming that we're decaying exponentially, let's estimate the population of the town 10 years from now. Well, we know the population now is 250,000, so we can plug that in for P0. We're told that in 25 years, the population is supposed to be 100,000. Putting 25 in for T gives us this equation to solve. Divide by both sides by the 250,000, we get the equation a to the 25th equals 0.4. We need to take the 25th root of both sides, or raise both sides to the 1/25th power, and we get a is about 0.964. Now we can estimate what the population is in 10 years. We can do the 250,000 times 0.964 raised to the 10th power, which gives us approximately 173,286 for the population of the town.